For video 4 of intersections, unions, and compound inequalities, we're now going to look and see how we can take the union of two inequalities, or in other words, a compound inequality. One thing to keep in mind as we start looking at these examples is when you are looking at a union, as opposed to looking for answers that have to work for both of the inequalities, you are just going to list out answers that will work for one or the other. So as long as one of your inequalities works, you're good. So our first question, we have x is less than -5, or we have x is greater than 4. So I'm going to go ahead and go straight to my number line first and start plotting and shading. So because I'm using a strictly less than symbol, I'm going to leave an open circle over -5, and I'm told that I should shade to the left because it's a less than symbol. For x is greater than 4, again an open dot over 4, but this time I'm going to shade to the right. So remember, I want to list out all of the answers that, I just want to list out all the answers. So in this case, I'm going to be shading, or I'm going to be interested in all of those solutions and all of these solutions. Remember, this time we're looking at a union, so we don't care about intersection. We just want to list out all the solutions. So when it comes to writing out our interval notation, I'm going to say, okay, it goes from -infinity to -5, and I'm going to close that because what I want you to note here is that you kind of have a dead zone. There is no shading here, so we don't want to include any of these numbers or any of these values. So in order to kind of skip over this dead zone, I'm going to use my union symbol. So I'm going to connect my solutions that I have on the left, and I'm going to connect them with the ones that I have on the right. Those start at 4 and go all the way to +infinity. So this is how I would list out all of my solutions in interval notation when my solutions also have a dead zone in the middle. The set builder notation is kind of underwhelming in a sense. So again, we're going to start off with our curly Q bracket. We're going to address what variable we're referring to, and we're going to say x is less than -5 or x is greater than 4. Essentially, I've just rewritten the problem. Let's go ahead and take a look at a little bit more of a challenging problem. So now we're going to look at the union between the inequality 2 minus x is greater than 1 and the inequality 4x minus 9 is greater than 7. So to begin, I'm going to remove 2 from both sides. And this is going to leave me with -x is greater than -1. But I want to get rid of that negative that's being multiplied with the x, so I'm going to divide both sides by a -1. In doing that, a red flag should be coming up and I should be going, okay, so I need to flip the direction of my inequality. And -1 divided by -1 is +1. For my other inequality, I'll add 9 to both sides. So I have 4x is greater than 16. And again, I'm going to divide both sides by +4 to get rid of the multiplication of +4. And this is going to be x is greater than 4. So let's go ahead and look at the graphical representation of this. So to begin, we're just working with strictly less than, so I'm going to put an open circle over the 1, and I'm going to shade over to the left because that's where all the values are less than 1. And for x is greater than 4, again an open dot over 4, and I'm going to shade to the right. So again, they're kind of diverging, they're going in opposite directions. So when it comes time to write the interval notation of this, I'm going to say, okay, I need to include all possible solutions, so not just the intersection, because again, we're using or, which is referring to union, which is saying, hey, list everything out. So in this case, we're going to work with -infinity to +1, and again, using a parenthesis next to that 1 because we used an open circle. I do have a dead zone that I have to be aware of, so I'm going to use my union symbol to connect my intervals. And from here, I'm going to go from 4 to +infinity. And again, if we are writing out the set builder notation, we're going to do x such that, well, x is less than 1 or x is greater than 4. And there are our 3 different ways of presenting our work. Okay, so now it is your turn. I want you to go ahead and take a look at this problem. Present your work as a graph using your interval notation and using your set builder notation. When you're ready, please press play on the video and we will review. So this result might look a little bit different than the solutions of the previous two examples that we've worked on. Solving our first inequality of 6x minus 2 is greater than 4 will give us a result of x is strictly greater than 1. And solving our other inequality of 3x minus 5 less than 1 gives us a result of x is strictly less than 2. So here is where this problem might start to look a little bit different than the previous ones that you've been working on. Notice in this case, it looks like we kind of have this overlap that is happening between 1 and 2. The first thing that I want us to kind of call out, though, is that we are not working with an intersection problem here. We're working with a union, which is denoted by the word or. Remember, a union is asking you to find any solution that will work for either of those inequalities. Another way to think of this is just give me a number that will make one of them work. Both of them do not have to work for me. I just need one of them to work, so it's a little bit more laid back. So the next point of concern might be the open circles that we have happening here. You might be tempted to say, well, I won't include those because I have an open circle in that situation. But you need to kind of take a step back and look at the entire picture on your number line. So for example, if we look at the open circle on 2, usually I would say, yeah, don't include that. You're not allowed to work with that. But remember, union wants to take into account all possible solutions here to at least make one of those two inequalities work. If you go to the purple line, for example, notice that when I had shaded it, it did cover the 2. So because there is a shading from the other inequality that covers the 2, I'm allowed to work with that 2. Similarly, when we start looking at the positive 1 here, you might be thinking, okay, I have an open circle over the 1. I'm not allowed to use that. But our green inequality friend here, when we were doing that shading on the number line, it does include the 1. So I'm allowed to include that as well. As a result, if you use your imagination and kind of pinch those pink lines down, notice that it would actually cover the entire number line. So this is why when we move to interval notation, I'm saying I can use any number from negative infinity to positive infinity. Another way when looking at this from the set builder notation perspective would be to write this with our curly Q brackets to identify our variable of x such that x is a real number. In other words, a real number can be an integer, so positive, negative, 0. We can include rational numbers, irrational numbers, pretty much anything on the line. If you were to close your eyes and just randomly place your finger somewhere on the number line, you have found a solution that will either satisfy both inequalities or one of those inequalities. There's never going to be a situation where you would get two false statements. So in this situation, we're essentially saying you can't go wrong.